Hi, this is Mrs. May. Today we're going to be looking at lesson 7.1, solving systems by graphing. We have a couple of equations that we need to find the coordinate point that solves both equations. So as we're looking at equations, there's a couple of things that we can do. You could create a t-chart, which is an x and y in out table. You could set x to 0, y to 0, and find your x and y intersect points and then draw a line. Remember that these are linear equations, so that's going to make a straight line on a graph. Or you can set these into a slope-intercept form and change these around into a y equals. Whatever system you like to use in order to graph is up to you. There is no wrong or right way as far as which way you approach these. So I'm going to show you on just this first equation or set of equations a couple of different ways that you could solve these. So as we look at this first one, I'm going to change this first equation into y-intercept. So we have this equation x plus 2y is equal to 5. When I move the x to the other side of the equation, that makes it a negative x. So I end up with 2y equals negative x plus 5. It's a positive 5. And then when I divide by 2 on both sides of the equation, I end up with an equation that looks like y equals a negative x divided by 2 plus 5 halves. Then this gives us a y-intercept of 5 halves, or 2.5, and a slope of, when you look at this, we've got 1/2, and I'll rewrite this. We would have a negative 1/2 times x plus 5 halves. Gives us a slope of a negative 1/2. Now this is a little trickier to try to graph. This would probably not be the way that I would approach this problem, simply because you're ending up with some fractions, and when you're graphing, it's difficult to make sure that you have your halves in the right place. So this is probably not the way I would do it. The other option that you could do is to set 0 for your x and solve for y, and set y for 0 and solve for x. You did this on your last assessment. So if we have x set to 0, so if this is 0, that leaves us a positive 2y is equal to 5, and we know when we do 2y equals 5, we end up with y equals 2.5 or 2.5, which is what we had when we were solving our last problem. And then when we set the y to 0, so when we set y to 0, we end up with x is equal to 5. So we would have x is equal to 5. Now those are certainly two coordinate points that are easy enough to plot, and you could put those onto a graph and then plot those points. I don't have a graph on here. I have it on my next one. That's fine. So that is just one way. You could end up with two coordinate points, plot those, draw a line in between and through them, and then you'd have that first line. And then you could do the same thing for your second equation, where you could set x to 0 and y to 0, and then do the other coordinate point. So if we set x to 0, we end up with 3y is equal to 3. That means that y is equal to 1. And if we set instead the y to 0, which takes care of that, we have 2x is equal to 3. So we would have 3 halves as our x. So a couple of different ways we'd have these two lines. We could plot those and find the intersection. And then the last way that you could do this is to certainly set up a t-chart. Now you wouldn't necessarily have to do the 5 points like we've been doing. You could do -2, 0, and 2, and just kind of split those things up and create some coordinate points based on -2, 0, 2. Running x through your problems here for that one, and running x through your problems here, and then finding your y coordinate points. So those are just 3 different ways that you could approach solving for these equations. Now, remember, we're looking for the coordinate point that solves both of these equations. Now, once you graph these, you're going to end up with a coordinate point. When you have that coordinate point, you need to put that coordinate point, substitute those numbers back into both equations and make sure that they are true statements for both equations. So we're going to give this a try on an actual graph here. And you may want to pause the video just to write down some notes here. Solving the system of equations by graphing, I would certainly make sure that you write down all of this into your notes and then make sure that you're writing the equations. So let me go back here and just erase that. So make sure you pause the video and take the time to do that. As we look at equation 1, we have negative x plus y is equal to negative 7. I personally just prefer to do setting each one to 0. That to me is the quickest way for me to solve equations. It may or may not be the quickest way for you. So again, you have the 3 different options. I'm just going to choose this one for this equation. So this is equation 1. And this is equation 2. And so let's substitute in. We've got a 0 for x. So when we zero this out, that tells you here that y is equal to negative 7. So I already have my first coordinate point by doing that. When I zero out my y, it tells you that negative x is equal to negative 7. We know that 2 negatives make a positive. And we would also have to think about, okay, if I multiply this side by negative 1 to get to x, I also have to multiply that side by negative 1 to get to x, or to solve. So this will give you positive x is equal to positive 7. So I now have my 2 coordinate points for that equation. I've got 0, negative 7, and 7, 0. And I can plot those points. So I'm going to move my graph up a little bit. So we've got 0, negative 7. And as I count down, there's 0, negative 7. And then my other coordinate point was at 7, 0. And then I could draw this line in between, down a little bit, just in case it intersects down here. I have one line already drawn for that first equation. Second equation, setting x to 0, takes care of that. We've got 4y is equal to negative 8. When you divide the 4 on both sides, you end up with negative 2. Then when we set y equal to 0, that tells you right there x is equal to negative 8. Because 4 times 0 is 0, and it just tells you x is equal to negative 8. So now I have these 2 coordinate points for my second equation. I've got 0, negative 2, a line there, and negative 8, 0. Here. And then when I draw these lines, you're going to see that they intersect. Now, the problem with drawing, and especially on a smartboard here, is making sure that you have a good intersection point. The closest point that I could see in drawing this freehand is 3, negative 3. And it looks like it's crossing at 3, negative 3. But the only way to know for certain if that is the true answer is to put this 3 for x, if we say x is 3 and y is negative 3, and putting that into those equations to make sure that they are true statements. So when we go back up to our equations, and I'm going to write this up here so that we have it. I'm going to do some erasing so we can get some more room here. So we've got x is equal to 3, y is equal to negative 3. And going back up here, if we substitute in 3 to this first equation, we would have negative 3 plus y is negative 3. Is that equal to negative 7? No, that's not true. So that tells me that my intersection point is not 3 and negative 3. So as I count again, it's possible that it's 4, -3, because as you look here, maybe my intersection point should have been here, and I had it at here. So I'm going to substitute it in here and say, okay, I think I was wrong, and it's really 4, -3. So I'm going to say, nope, I don't think my x was at 4. I think it, or at 3. I think it was at 4, -3. But again, the only way to double check, remember graphing is an imperfect way of solving systems of equations. We have done other ways. This is kind of an imperfect way, and the only way to make sure you have it right is to make sure that you have the right coordinate point and check your equation. So second time around, we said x is equal to 4, y is equal to -3. When we substituted into the first equation, x -4 plus -3, yes, that does work for that one, but I'm not satisfied yet. I want to make sure that it works for the second equation. If I say x is 4 and that y is -3, this gives me 4 times -3. I'm going to move these out of the way. So we've got 4 plus -12 equal to -8. Is that a true statement? Yes, it is. So as you can see from looking at this, this is the correct coordinate point. So again, just making sure that you go through to double check and make sure you have the right coordinate point before you proceed. Here's another set of equations. Again, I would set these equal to 0. So go ahead and stop this video, and I want you to go ahead and see if you can solve these on your own. Stop the video, do it however you wish. You could zero out x and y, you could create a t-chart, or you can put these into y slope-intercept form. So go ahead and stop your video. Okay, for those of you that paused the video, probably surprised you a little bit. I decided to do a t-chart on this one. And so I set up x and y tables of 2, or -2, 0, and 2. Came up with solutions of 1/2, 3/2, 5/2. And then on the other second equation, -2, 8, 0, 4, and 2, 0. Notice that this happened to give me my 2 intercepts here. So for those of you who did the zeros, that's fine. You should have ended up with 0, 4, and 2, 0. And when I crossed them, I actually drew this, it was pretty straight. Came out to a coordinate point of 1, 2 at their intersection point, ran them back through the equations, and made sure that they worked, and they did. So hopefully you were successful with that sample problem. Here's a real life situation. Remember that a linear equation, or if you think of y equals mx plus b, we know that's the slope equation. And we say that b is the y-intercept and m is the slope. This is also really a rate where you think of, okay, b is your intercept, yes, but that's also your starting point. If you think of your starting point in an equation, and the slope is your rate. So really, it's kind of a rate equation. So as you're looking at this problem, it says, in the fall, the Math and Science Clubs each created an internet site. You are the webmaster for both sites. It is now January, and you are comparing the number of times each site is visited each day. So I'm going to move this down here, and I'd like you to take a second to read this and create an equation. So we're starting with 400 daily visits. Notice that I have that as my y-intercept, and a rate of 25 daily visits per month, so 25x. Go ahead and write an equation for the second idea. Hopefully you wrote y is equal to 50 times x plus 200. Remember, we have a starting point of 200 daily visits, and they increase at a rate of 50 daily visits per month. I want you to go ahead and graph this equation. Okay, hopefully you've had the time to create a graph and answer this question. It says, it is now January and you're comparing the number of times each site is visited each day. Well, where they cross is that in 8 months, they will each have 600 total visits. So if we were looking at when is one going to overtake the other, you can see that it's at 8,600. Here's your practice problem for tomorrow. Have it done and bring it to class.